There you go. I'll turn it over to Josh to kick things off and present his screen and introduce himself and talk about ZB.
Awesome. Thank you, Michelle.
Thank you.
So there's something wrong with my Chrome right now. I can see people's avatars, but I can't see anyone's camera. Can you see me? My camera working?
Yes, we can see you.
Yes, yes.
Okay, awesome. So my name is Josh Wulf, and I'm a developer advocate at Camunda, and I work particularly with ZB and with Camunda Cloud, and I'm based in Auckland, New Zealand. And funny thing happened to me yesterday. I ran into a 220-pound barbell and broke 4 or 5 of my teeth in the afternoon. So I have a kind of a Kiwi accent, and now with my teeth like this, I'm not sure exactly what it sounds like, but if you have any trouble understanding me, just let me know, and just know that it's me, not you. I was going to say you should see the other guy, but it was a barbell, so the only thing that it got was a bit of my teeth enamel on it, and that was about it.
Oh, no. Well, I'm happy that you're able to still do this. Thank you so much for joining and continuing with this meetup.
I wouldn't miss this for the world, 100%. So in those questions that we did there, one thing that's kind of missing for me and understanding who I'm speaking with, like I actually know some of the people in here personally. Sandy Kemsley, obviously, extremely famous, spoke at CamundaCon last year, very well known in the BPMN scene. Mary from Camunda also. And then I saw 100% of respondents are using Camunda Community Edition, but I'm not clear on whether people are familiar with Camunda, the business process engine, or, you know, and then I'm talking about the differences between ZB and Camunda, or whether we have people who are like, what even is business process management? So just so I can get a sense of where to kind of pitch this at, it's the best way to find out, can people raise their hands, or do people just want to let me know? Like, are you familiar with, yeah, okay, 1 to 10. Good suggestion, Justin. So on a scale of 1 to 10, where 1 is I know absolutely nothing about BPMN or Camunda, never heard of it, just, you know, randomly clicked on something, you know, because I had nothing to do this afternoon, evening, whatever time it is of the day where you are. So that's 1, know nothing about it. To 10, I'm very familiar with Camunda and BPMN. So Justin's a 6.7, very specific. Michelle's an 8. Okay, Vadim's a 7, Becky 7, Esme 7, Vasily is a 3. Okay. Okay, great. So I'm going to roll with, okay, BPMN 5, Camunda 1. Okay, and I saw that we did have someone from MuleSoft here as well. So obviously, whoever that is familiar with BPM to some extent. Maybe not with the specifics of the Camunda engine. So I'll give a little bit of a kind of a background on the motivation behind ZB. I've got a presentation here. Now, if I can go to share my screen, let's have a look. Present now. Present a window. Yep, and I'll present my Chrome window. This one here, share. Okay, so this is a presentation. It has my name on it, Josh Wulf. It's a presentation called Scaling a Workflow Engine, but it's a presentation written by Dr. Deepti Akurnath, who is one of our engineers working on ZB, and she has like a doctorate PhD in distributed systems engineering. And so what ZB really is we took our existing, very successful, well-engineered, you know, mature business process engine, the Camunda engine, and reimagined like how would we rebuild this from the ground up if we wanted to make it massively scalable, like web scale. And this is kind of the common workflow engine architecture. classic. You have a workflow engine, and then you have a database. And as your workflow engine executes the different steps of the business process, it writes records into the database about the current state of the workflow. And if the engine crashes or is shut down for whatever reason, the state is persistent in the database. And when you bring the engine back up, it reads the state from the database and then continues execution. So generally, when you want to scale that architecture, you add more workflow engines to the front end, and then they write to the same database. Now, the problem here is that your database then becomes your bottleneck for scaling. So you have things like actually scaling that database layer itself, vertical scaling with more RAM, more CPU, horizontal scaling by clustering, sharding. But then you have things like database locks that can cause problems with contention, parallelization, dealing with problems like a database getting locked and then the lock not being released. So we thought about using some of the modern, massively scalable databases, and I don't mean MongoDB. We looked at using Cassandra for that. We tried that, and then we went to a completely different approach where we did away with the database completely. So ZB does not use a database. This is the architecture diagram for ZB. And what we do with ZB is we use an event stream or an event log. So we took a lot of inspiration from Kafka, which is a streaming event processing kind of framework. And if we have a look in the documentation here, this is the ZB documentation at docs.zb.io. And we use an event log where we just have an append-only log that we write to on the file system. And we write the different events that take place in the BPMN execution. So we have here's a command that comes in from a client saying, can you please create an instance of this workflow model? So then we write a create command to the log, it gets processed, and then once the workflow instance is created, we then write created to the event log. Then the first step in this process that we can see here is that a job gets created. So we first write the command job create, then that gets processed by the engine, and then it writes created. And then that job is executed by some task executor, and then we write in job complete. So it uses this append-only event stream log rather than a database. And what we do here is in the ZB cluster, so I'll walk you through each of the parts here, and we'll start in the middle. We have a cluster of engines here, ZB brokers, and each of these is writing to an event log, and then they're replicating the event logs between them. And there's actually no way that you can inspect what's happening in these brokers. Whereas with Camunda, you can have a look inside the database and get some idea of the current state or what's happening by looking at the database using your normal database visualization kind of tools. The event logs inside these brokers are pretty much a black box. And so the way that you can get any kind of visibility on what's happening inside the engine, what's the state of these processes, where are things up to, is that event log gets exported. And you can write your own exporters. There are a bunch of different exporters that you can use, but the one that comes out of the box with ZB is an exporter that works with Elasticsearch. So it exports all of the events that happen into Elasticsearch, and you can put that into a data lake. And you can do things like manage retention policies there, like how much information do we need over what period of time, and then you can shift them like that AWS Glacier kind of idea where you ship off historical data into a low cost, high latency storage, and then you keep your operational data in a, a relatively higher cost, lower latency storage so that you can get access to it and see what's happening. On the front of the ZB cluster, we have a gateway, and this gateway is the communications point between your clients and the broker cluster itself. So internally in here, I can't tell whether you can see where I'm pointing with my mouse or not, but inside the broker cluster, communication between the brokers is done using the Raft consensus protocol. And that's how they decide who's leading. That's how they distribute the information about the event log so that it gets replicated. Between the gateway and the broker, we use a protocol called SBE message pack. But then between the gateway and the clients, we use a protocol called Grpc, which is Google's RPC protocol. It's a very efficient, low latency protocol, binary protocol that's executed over HTTP2. And one of the things that Grpc does is it opens an HTTP2 connection between the client and the cluster, and it holds that connection open. And then you can just send commands back and forth along that connection. So it's much more efficient than using REST, because with REST, you have like a setup and a teardown overhead for each of your requests that you send. But because Grpc uses a persistent connection, it's a lot faster. There's like most of the data that's flowing on the internet today is REST requests. But then there'll be a bunch of stuff these days that's like streaming video over WebRTC or Netflix. But apparently internally, inside data centers around the world, more than 60% of all the traffic is using Grpc because of its efficiency. So if you're familiar with Camunda and the way the Camunda engine works, with the Camunda engine, you can create your BPMN diagrams. I have a picture of one here. Yeah, here's one here. You create your BPMN diagrams, and you have a few options of how you deploy the engine and also how you implement the executors for your service tasks. So with the Camunda engine, you can deploy it in like a client-server kind of architecture. So you can have like what's called the external task worker pattern, which is where the executors for each of your service tasks are externally running processes in another CPU somewhere else on the network, and they actually poll the Camunda engine over REST for work. Another model that you can use with the Camunda engine is you can write the executors in Java code, and then they execute inside the engine itself. It's another model that you can use. And then a third approach with the Camunda traditional engine is that you can actually embed the engine inside your Java application itself. So out of these three models, only one of these is applicable to ZB, and that is that client-server approach where your clients request work from the engine and then execute it in another CPU, another memory space somewhere else. So the ZB model maps onto the external task worker pattern of the Camunda engine. So there's no running execution code in the same JVM as ZB. And I think it is actually possible to embed the ZB broker into your application, into a Java application, but that's really not the design of ZB. There's no scaling at all in that model. So if I go back to here, so there are two kind of aspects to this massively scalable model that we've developed, and that's scalability and fault tolerance. And so there are three basic concepts with ZB. So there's the event log, which we looked at. There's this idea of partitions, and then there's replication. So if we have a look at event log, it's a single thread writing to the event log. And there is one event log per partition. So we've been doing a lot of work on performance tuning ZB. One of the tricky things about building a distributed system like this is that your bottlenecks, before, if we looked at the classical model, you had a bottleneck going into the database. So what we've done now by creating this distributed system is we've gotten rid of that bottleneck, but the trade-off with that is that there are now potential bottlenecks all throughout the system. Performance is kind of distributed throughout it. And one area obviously is going to be this event log, because it's an append-only log and it has a single thread that writes to it. So this is a point of contention for the system. We kind of looked at this previously, where it creates the, I'm about to do this, I just did that, this is about to happen, this happened. This is the event stream. It's kind of like event sourcing, if you're familiar with event sourcing as a architectural kind of design pattern. So yeah, it's an append-only log. It has a single writer and it's sequentially processed. So the way that you scale these event logs in the system is that you need to have multiple partitions. So each partition, which is kind of like a database shard, each one has a single thread that writes to it. So you create more partitions to get more writers for event logs. Otherwise, your system will be CPU bound, and well, no, it'll really be IO bound with that event log because you've got a single thread writing to it. So you add more partitions to allow, it's like the gateway does like a round robin on the partitions. And then to replicate the partitions, you set up a replication between the different brokers. This gives you an idea of the kind of horizontal scalability that we can get. This is like these numbers are actually changing all the time. And for users who started using ZB back in the earlier days, they actually get more throughput than the most recent versions get. But the most recent versions have a lot more stability in them than the earlier ones do. So we've kind of stabilized it, which has reduced the performance. Now we're working on bringing the performance back. But here you can see we've created it at some point. This was in 2019 in August, so just over a year ago. We created a cluster which had like 25 brokers in it. And you can see that the scaling performance here is pretty much linear, that as we add more brokers to the cluster, we just get more performance, which is what we wanted to get with this. So there's the database has no longer become the limiting factor. It's just more brokers equals more event logs equals more performance. What will slow this down, I'm not sure exactly how this test was done, but this might have been done with no fault tolerance replication. As soon as you add in this idea of replicating the partitions, the performance will go down, but it makes the system more resilient to failures. So what happens in the fault tolerance replication is that when an event is written to the event log, like I had a request to start a workflow instance, and then that gets written into the event log, and then the raft protocol is used to replicate that to all of the replicating brokers. So let's say that you have a three node cluster, you have 3 ZB brokers, and you have 3 partitions, and you have 3 replicas. That's pretty straightforward. 3 brokers, 3 partitions, 3 replicas. So the gateway gets a request, start a workflow instance, round robins it to broker number 1. Broker number 1 writes the workflow instance create command and then replicates that to the other 2 brokers. As soon as those 2 brokers respond with, yep, I got that, I wrote it to my log, now it gets executed. So you can see that as soon as you add replication into your system, you have added this communications overhead to talk to the other brokers. So when we're advising people, if they're testing ZB for performance, to see whether can this system actually meet the performance requirements that we have for our problem space solution that we're building, is that they first of all test it with no replication at all. Because if you find that ZB cannot, run fast enough and respond fast enough to your requirements with no replication, it will never get faster without replication, except in some very specific circumstances where we found that it actually ran faster with replication. So I did a 2.5 hour live stream with one of the consultants at Camunda, Falco, and we can share the link to that. It's on YouTube, and he has a spreadsheet with literally hundreds of the different configuration parameters that you could possibly do, all kinds of tuning parameters, number of threads, CPUs, amount of memory, different configuration parameters. And he's been systematically exploring that space just empirically by trying different things. And we would never have thought that turning replication on would actually make the system faster, but he found a specific situation where it actually does, and we don't understand why yet. But as a general rule of thumb, when you're doing performance testing on ZB, the best thing to do is to do it with no replication at all, because generally speaking, it will go slower once you start replicating. And then some people have been asking about doing multiple AZ replication. So they're like, what happens if the asteroid comes and takes out the data center where our ZB cluster is running? We need to have another ZB cluster running in Siberia or somewhere else that can just automatically take over the workload transparently, which is pretty much what happens in the failover scenario, where when the leader dies, the raft protocol detects that the leader of that partition has died, but now you have two other brokers in your cluster that know exactly what is happening in the exact state, running state of the system, and they can just pick up from where that last one left off. Now, if you have those, if you're replicating across data centers, then that raft protocol is doing all of this kind of synchronization and replication across data centers, which makes your system run very, very slowly. One of the kind of classic use cases that people are using ZB for in BPMN is they get a REST request in from a client, from a some kind of web client, and then they'll execute a business process, and then they'll send the result of the business process back to the web client over in the REST post response. And so, in order for there to be low latency for the user, that they hit enter or they click send, and then they're waiting to see what the result is, you want to get that back to them in 50 milliseconds, 200 milliseconds, like that. You don't want it to be coming back after 3, 4, 5 seconds. But if you're doing multiple data center replication with ZB, it's going to take seconds to get anything back. So you can do multiple data center replication if you don't have this low latency requirement. But for low latency, you definitely want to have all of your nodes in the same data center. So this is an example, the example that I mentioned before, although this one has 2 partitions rather than 3. So the easiest way to actually test out ZB right now is you can pull the container from Docker, run it on your local machine, and if you go to Awesome ZB on GitHub, you find a list of all the kind of community contributed bits and pieces. There's quite a rich community around it right now, and you have programming libraries for it in Java, Go, C#, Delphi, Ruby, Node.js if you're into JavaScript, Rust, a couple of different Python ones, and even one that runs as a GitHub action. So you can pull it down from Docker and run it. There are also Helm charts if you want to run it in Kubernetes. But probably the easiest way, if you just want to get a feel for it, try it out, test it out, is to use Camunda Cloud. So if you go to camunda.io, there's actually a hosted instance of ZB there, a hosted service. And this was one of the reasons why we created and went into this whole approach of like, how do we build a massively scalable, distributed workflow engine that executes BPM. One of the things that motivated us to do that was the ability to do exactly this, to run a hosted service. So when you come in here, I'll switch organizations, you can get a free account at camunda.io, and you can create a cluster in here, and you deploy your workflows into this cluster. This is a new feature actually that just got added in the last week or two, where you can actually create models in the Camunda Cloud console itself. So at the moment, if you're hosting it in your own Kubernetes infrastructure, or you're running the binary, at the command line, or you're using the Docker image, you need to download the ZB Modeler, which is an Electron application. Make your model in there, and then deploy it into the cluster. And there's actually a button in this ZB Modeler that allows you to deploy it directly into Camunda Cloud from the modeler itself. Otherwise, you need to use the command line client or write some code to deploy into the cluster. But now you can actually create a model in your web browser and deploy it straight into the cluster from the web, which is pretty cool. It's trying to reduce the amount of friction to the lowest amount possible, just so that you can get started and try things out. Then when you've got your cluster created, you can create clients for it. And this is where you get your client APIs for your client libraries. And then in the cluster overview here, you have view and operate. So earlier I spoke about the inability to inspect the state of the engine. But what Operate does is Operate is a graphical interface that interrogates the Elasticsearch export and then builds a picture of the state of the engine. So if I go into View and Operate.
So Josh, is Operate similar to Optimize? Because I posted a question, and we can take questions after if you want. But I was wondering if Camunda has any future plans to allow Optimize, that feature that allows you to do all of this inspection and see the bottlenecks, to be leveraged by the ZB workflow engine. But is Operate similar?
Operate is, yeah, it's kind of similar to Cockpit and Optimize. And, we do have plans for bringing a lot of that functionality over into Operate. This is basically what's available right now, which is you can pretty much inspect running workflows. So if you've used Optimize or Cockpit, then some of this will be familiar to you. There's no heat maps in here, but I can see the tokens from the various workflows. Even if I turn on finished instances, I can see here it's not quite a heat map, but it does give me that kind of rough idea. But this Operate is meant for kind of like operational interaction with the system.
Gotcha.
So you can see that some incidents have been raised at various points where something's gone wrong. So these are things that require manual operator intervention to fix the business process. So if I have a look at all the incidents, and what we're looking at here is I have like a kind of a side project teaching children how to program JavaScript in Minecraft. And I built the system using Camunda Cloud just as a useful kind of test. So here's the business process here, and you can see something's gone wrong at some point, and then we can find out, what went wrong, and then fix it, hopefully. In this case, I don't think there is a fix for this problem. But if I click on here, it tells me exactly what went wrong and where it happened. So you can actually go in and Operate and modify the variable payload of the process and then retry the operation. This one looks like a programming error because this should actually never happen. Fail to extract the correlation key by this never gets called. So it looks like application logic error there. Yeah, so this is the easiest way to try it out. I mean, you can pull these containers. There's a ZB Docker Compose repository, so you can run it with Docker. Pretty much covered in the Getting Started tutorial in the documentation at docs.zb.io. You can host it in Kubernetes, or you can just run Camunda Cloud. I recommend running it in Camunda Cloud to get started, because then you can just do away with all of the configuration. You know, did I get this thing to start or to run properly? It's hosted, it's already running. All you then need to do is worry about your application code or your BPMN models, which you can build in here as well. Okay, do we have any more questions? That UI looks 100 times more intuitive than Cockpit. Yeah. Cockpit is extremely powerful, but with great power comes oftentimes great complexity.
Just a quick question, just because I haven't looked at it recently.
Go for it.
Far behind in the BPMN spec is because I know that they're not up to spec as much as Camunda.
Yeah, great question. So in the documentation, it has BPMN coverage. And so you can see in here which ones are covered and which ones are not. So the ones that are this kind of orangey color are covered. And then the ones that are in black are not covered yet. So we, you know, you can see here, it's like, we've kind of gone with Pareto's 80-20 principle. You know, we think that these are the 20% of the symbols that allow you to do 80% of the functionality that you'll need to do. And then in a lot of cases, when I've been building things, I've like simulated some of these other symbols by building kind of little state machines using the other symbols. And then we have, you know, requests coming in from users about which one should we support next. But this gives you an accurate picture of where we're up to right now. I'll drop that into the chat.
Josh, this is Vasily. I have a question.
Go for it, Vasily.
Yeah, my question is, you mentioned the 3 different deployment models or approaches.
Yes.
One was the, and my question is, based on your experience, based on your hosting, which approach is the most popular? In other words, microservices, standalone, engine integrated. Which one is the most widely used?
That would be for Camunda that you're asking, because with ZB, there's only one way to deploy it.
Got it. Thank you.
So was your question about ZB?
No, my question was regarding the Camunda when you were doing intra.
Yeah.
Different ways.
Yeah. It's really quite a mixture. Yeah, it's a mixture between the different ones. And some of the kind of considerations that come into that is about the operational complexity of managing the system. Like if you have a single client server kind of model with one view of the data in one place, it makes it real easy for you to manage it. When you do things like embed the engine into each of the applications, then, you know, upgrading the engine requires redeploying the application. And then you need to either inspect the data from each of the applications independently or fuse them all together by connecting them, for example, to a single database. So it really depends on your operational requirements and the performance requirements, and also your organizational requirements about redeployments. So there are a bunch of factors. In other words, it depends. Now I sound like a consultant.
Yep, but thank you. And yeah, I agree with you. It probably depends on the scale of the organization, how the established processes, what is the normal practice. But yeah, I've got it. Thank you.
You're welcome. Any other questions? think that's pretty much what I had to show you. Oh, actually, I'll show you one other thing. When you use Camunda Cloud, you get Operate baked into it. So this is just one place, all deployed, all managed. It's running in Kubernetes. It's pretty cool. It's the easiest way to start playing with ZB. 100% recommend it. There's another really cool project written by one of the engineers who works on ZB. It's called Simple Monitor. Actually, ZQS is pretty cool too, but Simple Monitor, it's kind of like Operate, but it does a few things that Operate doesn't do. So the way that Simple Monitor works is you load a Hazelcast exporter into the broker. So you can write your own exporters to export to anything. I wrote one that triggers a webhook whenever you have an incident, so you can like send it to Twilio or to Slack or something. But this uses the Hazelcast exporter, and then it actually puts the broker historical state into a Postgres database. And then it has its own web app that runs on front of that, where you can inspect processes pretty much like you can in Operate. One thing that you can do in Simple Monitor that you can't do in Operate yet is you can create a new instance, a workflow instance. You can't, however, run Simple Monitor against Camunda Cloud. The great thing about Camunda Cloud is that it's fully self-contained. It's just there. You just sign up for free. It'll provision a new cluster with everything configured and running. The downside of that is it has a limited ability for you to customize it. But I would start there, and then, you know, if you run into some kind of limitation, you can explore running it locally and adding in integrations like Simple Monitor. And then this one, ZQS, which we're talking about, can we get this into Camunda Cloud? This is a ZB query service, which allows you to query the status of the system over GraphQL. So you can export either using the Elasticsearch or the Hazelcast. And then once you get that data out into this other database here, you can now query it through this ZQS layer over GraphQL, which is very, very powerful. You don't have any access to the Elasticsearch instance of Operate. So in Camunda Cloud, my cluster is running. It's pushing its data into a hosted Elasticsearch cluster. And then I have a corresponding Camunda Operate instance, which is reading from that Elasticsearch cluster, but I can't access Elasticsearch myself externally. So if there are things that you can do in here, someone asked me the other day, actually, is there any way that we can do things like collect a list of all of the incidents from Operate? There's no Operate API for you to do that. So the only thing I could suggest to him was web scraping. I mean, anything that you can do as a human being by clicking on a web page, you can program a bot to do, but it's far from the ideal way to do things. But if you're self-hosting or running it on your local machine, you can run something like ZQS and just GraphQL query it.
I guess I have a question that's actually related to my previous one about how much coverage there is. What would be a reason why you wouldn't want to use ZB over Camunda? Other than the coverage factor, obviously.
Why you would not want to use ZB over Camunda?
Yeah, exactly.
ZB is really it's still an emerging technology. So we say that it's production ready in certain use cases, but we wouldn't generally recommend it for everyone over Camunda at this point in time.
Do you have a roadmap for when you plan on being production ready?
Well, it's interesting how we do things at Camunda. Like I joined Camunda from a company that was evaluating ZB and Camunda as like solutions for our next generation microservices project. And as a developer working in that company, something that really attracted me was in the documentation, they had these little ads on the side, and it says, at Camunda, we don't do estimations. And then in the kind of like talking to the consultants calls that I was having with them, I just kind of brought that up and said, I noticed in your documentation, it says that you guys don't do estimations. Like, how does that work? Because we're doing our sprint planning and we're doing estimates and stuff. And we're like, how long is a piece of string? How are these guys doing this? So what Bernd told me was, what we do is we decide on one of two things. Either we decide on a definitive feature set, or we decide on a definitive timeline. And if we're on a definitive timeline and we're releasing on that date, then on that date, we release whatever we have ready at the time. And if we're doing a definitive feature set, then we release those features when they're ready. And we don't like set a time for that. So at the moment with ZB, it's really working on that feature set rather than like to a timeline. So there's no timeline, you know, available that I can commit to about that when it would be ready. Coming soon is all I can say, really.
But how often do you do your releases?
So the ZB releases every quarter. We do a release. So we actually have 0.25 coming up pretty soon.
Okay, cool.
And then they'll have a certain, you know, number of features in them each time. And those are really driven by community demand. So what people are asking for, like what's missing for people. You know, what are the symbols that they really need to do their use case? If we can't figure out a way for them to get around that, we'll add it to the backlog of, okay, let's put this one in next. People are upvoting them, that kind of stuff. I did a consulting gig at a telecom company down here in Asia Pacific at the end of last year. And we looked at whether they would go with ZB or with Camunda. In their case, I recommended that they go with Camunda over ZB because of one of the requirements that they had was that their data couldn't leave their building. So they couldn't use Camunda Cloud, obviously. So the benefits of having a hosted managed service is off the table. And then they already had Camunda deployed internally. So it was kind of like, you know, are you going to deploy another one that's completely different, or, you know, another one where you can leverage your existing knowledge and skills and everything. I see a link from Justin there. So yeah, so they went with Camunda, but then in other cases there have been like startups where they've never used BPMN before, they haven't used Camunda before, so they're not factoring in, you know, trading off like leveraging existing skill sets against doing something new, and they're a startup, so they have a much higher kind of appetite for like risk and like emerging technologies and taking advantage of that kind of first mover advantage. Like they're going to bet on building their capabilities and knowledge around this emerging technology so that they can take advantage of it as it becomes a competitive advantage in the marketplace.
I see Vasily has another question regarding the ZB deployment. How popular is the deployment on premise?
Deployment on premise with ZB is pretty popular. We get people asking about that all the time, and you know, people have been running it. There are companies I know of that are running it in production with no support from us. At the moment, our focus is really on Camunda Cloud and that managed offering there. It's a lot easier for us to support that, especially at this particular point in the evolution of the product, because when it gets deployed on premises, then there's like multiple variables that are like either undiscoverable for us, outside our control. Whereas in Camunda Cloud, because we control the entire infrastructure top to bottom, we know absolutely everything about the deployment, and we also have access to everything to be able to inspect it. So at this point in ZB's kind of life cycle, it's very challenging for us to be able to support an on-premises deployment. So I would only really recommend that for an organization that's like deeply technical. Like when we looked at using ZB at the company that I was working at before Camunda, we wrote our own Node.js client for it, which then became, you know, the community kind of JavaScript client. And we were happy with like even diving into the source code and submitting patches. So I wouldn't recommend at this point in time deploying ZB on premises for production unless you're comfortable with that kind of level of technical engagement with it, or you're prepared to like pay for Camunda Consulting to put someone in there to do that for you. Otherwise, you're best off seeing if Camunda Cloud can satisfy you know, your use case. And I think there's what Justin pointed to, which is BPM symbol coverage. And then the other thing that's a big feature now in that decision-making matrix is end-to-end execution time. Because with the current releases of ZB, Camunda is still faster at end-to-end execution than ZB is, although it doesn't scale to the same degree. Justin saying that the question is, does having it on-premise differentiate your business? Probably not. I guess at the moment with the way that Camunda Cloud is structured, it could, in the sense that you can do things like put ZQS in front of it, which you can't do with Camunda Cloud. But again, while you're like getting the advantage of that technical flexibility, you're also taking on the burden, if you will, or the cost, the technical cost of like maintaining and understanding the configuration. And I've walked developers through performance testing and discovered that they don't understand the core concepts of how partitions and replication work correctly. And you know, in a distributed system like this, just to kind of wrap it up with this last point, is that what we've done is we've unleashed the genie from the bottle. So we've gotten rid of that bottleneck and we've let the genie out of the bottle. But one of the consequences of that is that complexity is now distributed throughout the system. So you now have to deal with things like back pressure and overloading different parts of the system in different places. So you got to worry about like the entire impedance of it. It's like if you ever look at the plumbing in your house, it's all based on streams, and this system is now a streaming system. If you overload the pressure at one point, you can burst a pipe or, you know, break your hot water cylinder or something. So in the same way now, you have the system that is potentially massively scalable, but you now have to attend to the impedance and the pressure at the different points of the system. Whereas with the Camunda engine, it's not as massively scalable, but it's a lot more simple to configure and to tune. And that takes us to the top of the hour. So that's pretty much what I have for you today.
Actually, I just have one more quick question. How hard is the migration from Camunda to ZB?
Putting on my consultant hat, it depends. I mean, if it's possible for you to do the migration at all, like if you have the same you know, symbol coverage, like let's say that you're using in your Camunda deployment just the subset of symbols that are used in ZB, and you could just redeploy your model. The model XML is actually different. So, you know, the extensions for the executors are using a different namespace. So you'd have to rework all your models. Then you'd just have to, the easiest way to do it actually is, if you have a Camunda system now, if you're using the external task worker pattern, it's going to be a lot easier to do the migration. And the city of Montreal, they actually took the Node.js client that I wrote, and then they wrapped it with another layer of abstraction. It's called Workit, and it uses dependency injection, and you just set something at the top level about whether you're connecting to Camunda or to ZB. and then it will either use the Camunda external task worker client or the ZB node client to poll the engine for the work and then do the completion. So they kind of like wanted to use ZB, but they were like, organizationally, we're not in the right place to do that right now. But when they looked at it, they were like, if we build our application in this way using the external task worker pattern, when ZB is ready for prime time for us, then it's easy. It's just a configuration change to switch our client applications over to it. Yeah, exactly. You can even A/B test it to see, you know, things like throughput and response time. Yes, big up city of Toronto.
Any more questions for Josh?
Okay, that looks like it. Well, thank you for tuning in. If you have any other kind of questions or anything that comes up, it's pretty easy to get in touch with me. If you go to the ZB website at zb.io, down the bottom here, it says you can also join the discussion on the ZB Slack channel or the ZB user forum. So I'm active in both the ZB Slack channel and the ZB user forum. And we have like quite a community in both of those locations that can answer any further questions that you have, or you can ping me on there.
Very cool. Thank you, Josh. Thank you so much for presenting to us today and for coming to this meetup after this accident that you had yesterday. So I really appreciate your time, and everyone for joining tonight. Thank you.
Most welcome.
All right. Well, I'll stop the recording. And